Welcome to the third lecture of the chapter 3 in the course of the several variable analysis. So, where we are going to solve few numerical problems using the chain rule. Okay, so our first problem is that prove that f r2 to r, which is defined as this complicated function and is differentiable, and we have to find f dash. Let's start to solve this question. So we will try to take this function as a product of two functions and make it simplified in this form, and then we'll solve it. So we take it two function. So let gxy is equal e to the power x y square, and then we define g1 xy is equal x y square, and g2xy or g2t is equal e to the power t. So you can see that here g1 is a function from r2 to r, and g2 is a function from r to r. So clearly g is equal g2 composition gy. In this case, if we see that g2 and g1 are differentiable, then the composition function is differentiable. So now g1 xy is differentiable as it can be written as product of three linear function and like as L1 x is equal x, L2y is equal y, and L3y equal 1. And since linear functions are differentiable, so the product of three linear functions will be differentiable. And G2t is G2t is single variable and clearly differentiable. Therefore, G is equal G2 composition G1 is differentiable. Now G dash x h, this is equal by definition G2 dash G1 now let h is equal h1 h2 belongs to R2, then G2, then G dash xy operating on h is equal g2 dash g1 xy and then g1 dash xy operating on h. So this is equal. So g2, the derivative of g2 is e to the power t. So therefore it will be e to the power g1 xy and then g dash xy. So g dash xy is g1 xy is, so derivative of x. So this is y square h1 plus 2xy h. So now just substitute e to the power x y square h1 plus 2xy h2. Let note it down. This is as 1. Now we'll take another function mxy. So let mxy is equal square root of 1 plus 2x square plus 3y to the power 4. So in this case, we take another two function m1 xy is equal 1 plus 2x square plus 3y to the power 4. m2t is equal square root. By similar logic of the polynomials and power of the polynomials, power of the variables, clearly m1 is differentiable as a power of variables and m2 being m2 is also differentiable. So therefore m being the composition of two differentiable functions is differentiable. So therefore, for h is equal h1 h2 belongs to R2 m dash xy h is equal m2 dash m1 xy and then m1 dash xy writing on h. So this is equal square root t is 1 over 2 square root of m1 xy multiply. Now m1 is this one. So the derivative of m1 with respect to x, it will be 4x when we do the derivative with respect to x, the component will be h1 plus with respect to y it will be 12 y to the power 3 h2. So now substitute the value of m. So you will get it here 4x h1 plus 12 y to the power 3 h2 over 2 square root of m1 is 1 plus 2x square plus 3y to the power 4. So this is we can add as. Next is the consider the given function f. So now note that f of xy is equal g of xy multiply m of xy is differentiable being the product of two differentiable functions. And the product is given as f of xy h is equal g dash xy h mxy plus gxy m dash xy h. So therefore g dash xy, which we already calculated, the first equation, which is this one, e to the power xy square y square h1 to xy h2, e to the power xy square y square h1 plus 2xy h2, and then we write the m. So what is m? M is given as square root of 1 plus 2x square plus 3y to the power, and then we have g here plus g is given as e to the power x y square, and then the derivative m dash xy h. So this m dash xy h is this one 4x h1 plus 12y to the power 3 h2. So 4x h1 plus 12 y square h2 over square root of 1 plus 2x square plus 3y to the power this y cube. So this is after simplifications of h1 h2 we can have the final answer. So we can write it here. Let's say y square e to the power x y square plus 4x e to the power xy square over square root of 1 plus 2x square plus 3y to the power 4 h1 plus 2xy e to the power x y square square root of 1 plus 2x square plus 3y to the power 4, and here plus 12y to the power 3 to the power xy square over square root of 1 plus 2x square plus 3y to the power 4 h. So the final answer. Let's move to the our next problem, that A is a linear function from Rn to Rn and B is from Rn, and we define a function f Rn to R as f of x equal ax plus b whole square power 2. So first thing is that so that f is differentiable by definitions and find f dash. So let's have the solution for this part. So we have to show that to show f is differentiable, we have to show we need to prove that f of x plus h is equal to f of x plus th plus absolute value h epsilon h, where t is linear and epsilon h tends to 0 as mod of h tends to 0. Okay, so we start with this, and this is for all h belongs to Rn. So let's start with this f of x plus h. This is by definitions is equal a x plus h plus b whole square. So this is equal ax plus ah plus b whole square. This is because a is linear. This we can write it as this is equal ax plus b comma ah dot ax plus b ah. So we extend this dot product, we can rewrite this is equal ax plus b dot ax plus b plus 2 ax plus b dot ah plus ah dot ah. So this is equal absolute value of ax plus b whole square plus 2 ax plus b dot ah plus ah whole square. So this is given function f of x, and this is we denote it as th, and the last one we write it as absolute value of h epsilon h, where th is equal to ax plus b dot ah, and epsilon h is equal mod of ah whole square over absolute value of h. Now we are left that t is linear and epsilon h tends to 0 as h tends to 0. Okay, now epsilon h is equal absolute value of ah whole square over absolute value of h clearly greater than equal 0, and further mod of ah is less than equal norm of a absolute value of h implies epsilon h is less than equal norm of a whole square absolute value of h whole square over absolute value h, which is norm of a whole square absolute value h, and clearly tends to 0 as absolute value of h tends to 0. So therefore altogether we have epsilon h tends to 0 as mod of h tends to 0. And now the next part is th is equal to ax plus b dot ah is linear as a is belongs to L Rn to Rn. But if you want to prove that also, you can prove it in this way that H1, H2 belongs to Rn, alpha belongs to R. So therefore T H1 plus alpha H2 is equal to ax plus b dot a h1 plus alpha h2, which is linear because a is linear. So we can write it a h1 plus alpha a h2. And the distributive property of the dot product, we can write it here to ax plus b dot a h1 plus alpha to ax plus dot ah2. So this is equal t of h1 plus alpha t of h2. So therefore t is linear. So finally we will have, so therefore t is linear. So finally we conclude that f is differentiable. Dash x h, this is will be as the ta is the linear function, and then this is equal to ax plus b dot a. Okay, now next part is that we say that if f dash x equals 0, if and only if x is equal minus a inverse b. So to prove that, we have to first consider the a. Since a is belongs to L Rn to Rn, a is bijective. So for any v belongs to Rn, there exists h belongs to Rn such that ah is equal b. Okay, h. Okay, so as in the shown in the previous slide, so h is equal v. Then we have, so f dash x is equal 0. So this implies f dash x operating on h is equal 0. So this is equal to ax plus b dot ah is equal 0. So this implies to ax plus b dot v is equal 0. Since v is arbitrary, we must have ax plus b is equal 0. This implies ax is equal minus b. So this implies x is equal a inverse minus b is equal minus a inverse b. This is because as a belongs to L, Rn to Rn implies a inverse belongs to L, Rn to Rn. So therefore we prove that x is equal minus a inverse. Now the last part of this question is that we have to show this gx is differentiable. So for that we took two functions that f of x is equal ax plus b whole square, which is differentiable as proved in part A. Okay. Now this will gives you gt is equal ln 1 plus t square is a single variable function and clearly differentiable. Okay, so now what about g? Okay, so let's, this is not g, this is m, so empty. So what is g? So therefore g of x is equal m composition f x is differentiable, being composition of two differentiable functions. Okay, so now what is the differentiation? So g dash x on h, where h is from Rn, this is equal m dash f of x and f dash x on h. So this is equal m dash. So m is this. So m dash differentiation is 2 f of x over 1 plus f of x whole square, and f dash x we already calculated. So this is equal multiply 2 ax plus b dot ah. Now we substitute fx and then we will get the final answer. So this is equal to, this is ax plus b absolute value whole square over 2 over 1 plus 2 absolute value of ax plus b to the power 4 and then 2 ax plus b dot ah. So this is the final answer.